Welcome back to Bite-Sized Breakthroughs, everyone. Today we're diving deep into the exciting world of online advertising, specifically the rapidly evolving landscape of real-time bidding, or RTB for short. Joining me is Dr. Paige Turner, a leading researcher in this field, and Professor Wood Spectrum, a seasoned expert on the broader implications of digital advertising. Paige, thanks for joining us. Could you give us a quick overview of what real-time bidding is and why it's so significant?
Thanks for having me, Alex. Real-time bidding is essentially a digital auction that happens in milliseconds. It's the process by which advertisers bid on individual ad impressions as they become available, competing for the right to display their ad in front of a specific user. It's a radical departure from traditional advertising, where ads were purchased in bulk for entire campaigns.
That's a great way to put it, Paige. So before we jump into the details of RTB, let's take a step back. Wid, could you give us some historical context? How did we get from traditional advertising to this real-time auction-based system?
Sure, Alex. The evolution of online advertising has been fascinating. It started in the early 1990s with simple banner ads, but quickly moved towards more sophisticated models. The late 1990s saw the emergence of sponsored search platforms like Goto.com and Google AdWords, which allowed advertisers to buy keywords related to users' search queries. This was a major turning point as it introduced automated and keyword-based advertising. Then came contextual advertising, where publishers could sell ad space on their websites based on the content's relevance. But these systems still relied on preset campaigns and weren't as dynamic. The introduction of ad exchanges around 2005 truly revolutionized the field, creating a real-time marketplace for buying and selling ad impressions, allowing advertisers to bid on individual impressions as they're generated. RTB, therefore, represents the pinnacle of this evolution towards a highly automated and targeted advertising landscape.
That's a great historical perspective, Wood. So, Paige, what are some of the key contributions and innovations of this paper you're presenting today?
This paper is a comprehensive guide to RTB, addressing both the technical challenges and the opportunities it presents. One of the key contributions is its multidisciplinary approach. It integrates concepts from information retrieval, data mining, machine learning, game theory, economics, and optimization, providing a holistic understanding of the RTB ecosystem. The paper also presents various innovative models and algorithms developed for key aspects of RTB. These include models for user response prediction, bid landscape forecasting, bidding strategies, dynamic pricing, and fraud detection.
That's impressive, Paige. Could you elaborate on user response prediction? It sounds like a crucial part of the process.
Absolutely. User response prediction aims to predict how likely a user is to interact with an ad, typically by clicking on it or making a purchase. Accurate prediction is vital for both advertisers and publishers. Advertisers use it to target users who are more likely to convert, leading to better ROI. Publishers can use it to set reserve prices and optimize their revenue. The paper explores various models for user response prediction, including linear models like logistic regression and Bayesian probit regression, as well as nonlinear models like factorization machines and deep learning networks.
So we're talking about predicting click-through rates and conversion rates. That's quite a lot of data to process in real time. What kind of information goes into these prediction models?
Right, Alex? You're exactly right. We're dealing with massive data sets. The information fed into these models is incredibly rich. It includes user data like demographics, browsing history, device type, and location, publisher data like website content, ad placement, and ad slot size, and advertiser data like ad creative and campaign goals. This paper even explores the use of transfer learning to leverage knowledge from user browsing patterns to improve click-through rate estimation, which is especially useful for identifying lookalike users.
Transfer learning sounds fascinating. It's basically taking knowledge from one area and applying it to another. Wid, what are your thoughts on this approach? How does it compare to traditional methods?
It's a brilliant innovation, Alex. Traditionally, user response prediction models were trained independently for different tasks, but transfer learning allows for a more efficient and effective approach by sharing knowledge across related tasks. This is particularly useful in RTB, where user data is constantly changing and new users are constantly joining the market. For example, by using knowledge from user browsing patterns, you can quickly identify new users who are likely to be interested in a specific product, even if they haven't interacted with the advertiser's ads before. It's like taking the wisdom of the past and applying it to the future.
That makes sense. It's about learning from the data and using that knowledge to make more informed predictions. Paige, could you delve a bit deeper into the methodology of this paper? How are these predictions actually made, and how are the models trained?
Sure, Alex. The paper presents a comprehensive approach to model training, addressing a crucial challenge: the bias introduced by censored data. In RTB, only impressions that are won are observed. We don't have data for all the impressions that the advertiser didn't win. This creates bias in the training data. To combat this, the paper introduces a technique called bid-aware gradient descent, which utilizes a non-parametric survival model to estimate the probability of winning an auction. This information is then used to reweight the gradients during the training process, ensuring that the model learns from the complete distribution of impressions, not just the ones that were won. This is a significant advancement in the field, as it allows for more accurate and unbiased learning.
That's really fascinating, Paige. It's like accounting for the hidden data that we can't directly observe. So we've talked about user response prediction, but what about the other side of the equation, the bid itself? How does the paper approach bidding strategy optimization?
The paper proposes a general framework for bid optimization, considering various factors like campaign budget, auction volume, and the specific campaign KPI. It goes beyond simple truth-telling and linear bidding strategies, introducing the concept of quantitative bidding, where bids are based solely on the estimated utility and cost of each ad impression. It's a more systematic and data-driven approach, making bid decisions based on the estimated value of each impression, rather than relying on heuristics or intuition.
So, Paige, it's not just about how much you're willing to pay for an impression. It's about how much that impression is actually worth. That's a big shift in thinking.
Exactly, Alex. It's about maximizing the return on investment for each ad impression. The paper explores different bidding strategies for both first price and second price auctions, taking into account the complexities of each auction type. It also analyzes the impact of budget constraints and market competition on bidding decisions.
This is all very technical, Paige. Could you give us some concrete examples of how these bidding strategies might work in practice?
Imagine a campaign targeting users interested in travel. The advertiser might use a model to predict the likelihood of a user clicking on an ad for a travel website. This information, combined with the estimated cost of winning the auction, is then used to determine the optimal bid price. The paper explores various models for cost estimation too, accounting for the second highest bid in the auction and the distribution of bids within the market. It's a complex dance between predicting user behavior, understanding the market dynamics, and managing the advertiser's budget.
That's a great example, Paige. So we've touched on user response prediction and bid optimization, but the paper also delves into the world of dynamic pricing. Wid, could you shed some light on that aspect?
Dynamic pricing in this context is about publishers optimizing their revenue by setting the right reserve prices for their ad impressions. Imagine you're a publisher with a high-traffic website. You want to maximize the amount of money you make from selling ad space, but you also want to ensure that you don't alienate advertisers by setting prices too high. The paper explores several approaches to reserve price optimization, including optimal auction theory, which is based on the theoretical principles of auction design, as well as heuristic methods derived from game theory analysis.
So it's about finding that sweet spot for pricing, balancing demand and supply. Is it a simple matter of setting a single reserve price, or is it more dynamic?
It's definitely not a static process, Alex. The paper emphasizes the importance of dynamic pricing, adapting reserve prices in real time based on market conditions. The paper also discusses a new concept called programmatic guarantee, where publishers can sell a portion of their future ad inventory in advance at guaranteed prices, similar to futures contracts in the financial markets. This allows publishers to secure a predictable revenue stream while still leveraging real-time bidding for the remaining inventory.
That's an interesting development, we need. So instead of selling everything in real time, publishers can now lock in some revenue by pre-selling impressions at guaranteed prices. That sounds like a good way to manage risk.
Absolutely, Alex. It's about managing both revenue and risk. The paper also explores the use of ad options, which are essentially contracts that give advertisers the right but not the obligation to purchase future impressions at a predetermined price. This provides advertisers with more flexibility and control over their spending, while also offering publishers a predictable revenue stream.
It sounds like RTB is evolving beyond simple auctions. We're seeing more sophisticated contracts and pricing mechanisms. Paige, let's shift gears and talk about a critical aspect of the RTB ecosystem: ad fraud. What insights does the paper offer about this growing problem?
Ad fraud is a significant challenge in the RTB space, Alex. It's estimated that ad fraud costs the U.S. marketing and media industry billions of dollars annually. The paper explores various types of ad fraud, including impression fraud, click fraud, and conversion fraud. It also discusses the various sources of fraud, such as pay-per-view networks, botnets, and even attacks from competitors. These fraudsters are constantly devising new ways to exploit the system and generate fake traffic, which drains advertisers' budgets and erodes the trust in the advertising industry.
That's a big problem, Paige. How does the paper address the detection and prevention of fraud?
The paper highlights several promising approaches to fraud detection. One method is using co-visit networks to identify malicious website clusters. These clusters often exhibit unusual patterns of user co-visitation, revealing their fraudulent nature. The paper also discusses feature engineering techniques that are specifically tailored for fraud detection. These techniques involve analyzing features like click patterns, referrer URLs, device user agents, and IP addresses to identify suspicious activity. In addition, the paper explores the use of viewability methods, which help to ensure that advertisers are only charged for impressions that are likely to be seen by real users. This approach helps to filter out invisible or minimally visible impressions that are often generated by bots or fraudulent schemes.
It sounds like we're fighting fire with fire, Paige, using sophisticated algorithms to detect and combat sophisticated fraud. Wid, what are your thoughts on the future of RTB? With all these challenges, is there a clear path forward?
The future of RTB is incredibly promising, Alex. The industry is constantly evolving, and we're seeing innovative solutions emerging. We can expect to see even more sophisticated models for user response prediction, particularly in the domain of deep learning. Deep learning models have already shown impressive potential in various fields, and they can be applied to RTB to learn complex patterns from the massive datasets available. Furthermore, we're likely to see the emergence of more advanced bidding strategies, potentially using deep reinforcement learning to make dynamic decisions in real time. This will allow advertisers to adapt their bidding strategies based on real-time market conditions and optimize campaign performance in a more dynamic way. Additionally, we can expect to see new trading mechanisms, such as header bidding, which offers greater transparency and efficiency, and futures exchanges, which allow advertisers to lock in prices for future inventory. All of these advancements will work together to create a more robust, transparent, and efficient advertising ecosystem.
It's clear that RTB is not just about the technology, Wade. It's about understanding human behavior, market dynamics, and even ethical concerns. Paige, to wrap things up, could you highlight the main takeaways from this paper?
This paper has truly shed light on the complexities of RTB, revealing its potential and challenges. We've learned about the importance of user response prediction, the need for advanced bidding strategies, the benefits of dynamic pricing, and the crucial need to combat ad fraud. It's about finding the right balance between maximizing advertiser ROI, optimizing publisher revenue, and ensuring a fair and trustworthy advertising ecosystem. It's an exciting time to be part of this evolving landscape, and this paper has provided a valuable roadmap for the future of RTB.
Thank you both for a fascinating discussion, Paige and Wood. It's clear that RTB is a complex and dynamic field, with a huge impact on how we experience the internet. As this technology continues to evolve, we can expect even more innovation and change in the world of online advertising. We'll be keeping a close eye on this field and bringing you the latest breakthroughs here on Bite-Sized Breakthroughs. Stay tuned.